Today we are going to discuss about tide. Yes, again, but not just any tide. We are going to discuss about RTK tide, GPS tide and real-time tide. And believe me, they are exactly the same thing with different equipments are being used. As you carry out bathymetry survey, you observe and apply the tide as it happens in that area in real time. So today's agenda points are: what is RTK and real-time tide? Why real-time tide? Understanding the concept, advantages and disadvantages, and we'll also be discussing about best practices. So why real-time tide? See, most of the bathymetry survey is done in and around the ports and harbors, near the rivers and estuaries, in the Bay Area and also in the coastal zone. This tidal height and time can fluctuate greatly depending on which of the area that you are surveying. And the survey area can be very far away from the tide station or the benchmark. So variations in time and amplitude, that is height of the tide, is observed in this kind of situations. And I'm not talking about applying the tide data very far away from the tide gauge. And tidal variations can happen 2 to 5 kilometers away from the tidal station. So to counter that tidal variation and get a very precise and accurate tide data, we use a real-time tide of that particular area in exactly that time where the boat is carrying out the survey. There are a couple of different ways that we carry out this real-time tide observation, but the basic concept of this is exactly the same. So in this video, we'll try to see and understand the basic concept of the real-time tide and how best we can utilize that. So we have a benchmark here, and the benchmark tells me where is my sounding datum with reference to that particular benchmark. Now let's put a GPS or DGPS or DGNSS antenna on top of the benchmark, and we know the height of that DGPS antenna or the tripod. Now the DGPS antenna gives me the height from the ellipsoid. Let's call it C. So C is the height from the ellipsoid, B is the height of the tripod, and A is the height of the benchmark from a particular datum. So ellipsoid to the datum, the distance is equal to A plus B plus C, right? Now let's bring in our survey vessel, and we can measure the height of the survey vessel from the antenna to the sea surface. And the antenna on the survey vessel also gives me the height from the ellipsoid. So the ellipsoid to the sea level distance is equal to x plus y. It's clear, right? So the tide will be A plus B plus C, that is ellipsoid to datum distance, minus x plus y, ellipsoid to sea level distance, and that is the tide. We already know that tide is always above the datum except mean sea level. So tide is above the datum and depth is below the datum. So this is the simplest concept of your real-time tide. So as the boat is carrying out a survey, it can find the tide if we know the ellipsoid to datum distance. Now there are few questions that comes to our mind. How far away from a benchmark can we get in real time? Well, normally 4 to 5 kilometer is good enough to get a real time tide, but as per the AMHs, we can actually survey up to 15-16 kilometer from the tide station. Next question, do we have to keep the GPS on the benchmark while we are surveying? No, we do not. Once we establish the ellipsoid to the datum height by doing the GPS observation, we can remove the GPS antenna from the benchmark. But yes, for RTK Tide, you need to keep the base station on and transmitting throughout the survey period. Although the RTK GPS at the base station will still experience the fluctuation of the ellipsoidal height, it is still far better than normal DGNSS system. But RTK system is only as good as the accuracy of its base station. If the benchmark height, antenna height are properly not installed in the base station, then that error will be there in the rover too. Can we use DGPS, DGNSS in place of GPS? Yes, of course. With the DGPS and DGNSS, your accuracy of the height increases, so you'll get a better result. Can we do Rhinex observation on the benchmark? Of course you can do. You can do a 8 hours or 12 hours Rhinex observation on the benchmark, and that will give you a fantastic height, a beautiful height difference from the ellipsoid. So let's talk about advantages and disadvantages of real-time tide. A real-time tide data can give an excellent data in the Bay Area and inside a big harbor. You do not need to do any tide observation. So with this real-time tide, you can carry out the survey easily without having any tide station installed. This can also give you an excellent tide inside a river, but we recommend to have a multiple benchmarks or multiple stations observed to find where is the ellipsoid to datum. Now there is something called mean sea surface model or DTU21. This mean sea surface model is computed over 1993 to 2012 period from multiple satellites. They are observing the sea surface continuously and got a data, and that is called a DTU21 at 1 mile by 1 mile grid. So if you are using a mean sea surface model or DTU21, you can have the tide data from the mean sea surface. Now there are some disadvantages. DGPS, DGNSS ellipsoidal height in dynamic environment can be very high. You should have a calibrated motion sensor, calibrated DGPS receiver, and also calibrated gyro compass. Now RTK has a limited range and it needs a direct line of sight. Most of the time it works better up to 7-8 km in line of sight. Now, ellipsoidal heights varies from mean sea level every 2 km. So please keep in mind the ellipsoidal height is not same. There is a difference between geoid and ellipsoid every 2 km. There is a variation, so you might get a little bit of variations when you are carrying out a real-time tide or RTK tide. Let's talk about some of the best practices we can do to get the best of the real-time tide. So here you have your setup. What I propose that you use a tide gauge near the benchmark, wherever is your tide station. You use the tide gauge as a reference point, and whenever your boat is going out to do the survey, you have a check previously before you start off your survey whatever is your actual tide on the tide gauge and what is your real-time tide showing. And in the boat itself, I recommend you use a measuring tape every day to find the height from your antenna to the sea surface. See, we are talking about couple of centimeters of error in tidal height. Just ask yourself, will the couple of centimeter in tidal height really matters? At what depth you are doing the measurements? Will that couple of centimeter make any difference to your depth observation or not? I hope this video clarifies some of your doubt you have about your real-time tide, RTK tide or GPS tide. For RTK tide, the height is observed at the base station with reference to the benchmark and chart datum or the sounding datum and transmitted to the rover. If you are using a GPS, DGNSS, then you are observing the height. It's a fixed height between ellipsoid and the datum, and you are using that fixed height throughout your survey area. Ultimately, if the survey area is within 10 to 12 kilometers from your tidal station and benchmark, then your tide data should be within plus minus 2 to 5 centimeter. Thanks for being here, and I will see you in the next video.